Okay, our first question then is to complete the comparative bar chart for Sweden. I've done this one already. It is the second bar here, unfilled, because it is for 2018, drawn with a ruler up to 14. It doesn't matter how thick your bar is, okay? So I've aimed to just keep it the same as the others, but say for example it's a bit fatter, it doesn't really matter. 1 mark for that. Next up, how many more medals were won by Sweden than Great Britain? So what you needed to do here, of course it's in 2018, I might add. Oh sorry, it's in 2014. So we're looking at the filled bars here. So I'm looking at here, it's going to be 15. Here, it's going to be 5. So we're looking at the difference between 15 and 5. 15 subtract 5 is equal to 10. So 10 is the correct answer here. Okay, so our next question is to compare the total number of medals won by Sweden, Great Britain and Switzerland in the 2014 Winter Olympics. Now there's 2 marks here, so you can have any 2 of these. Okay, so just showing them all. Sweden won the most. Sweden won 4 more than Switzerland. Sweden won 10 more than Great Britain. Great Britain won the least or the lowest number of medals. Switzerland won the second most number of medals. Switzerland won 6 more than Great Britain. Any 2 of those is enough for 2 marks here. And well done if you have got that. The next question asks us to explain what quantitative data is. And this is quite simply data that is numeric, numerical, or numbers. You need to have only one of those words, so you don't need all 3, but you could say one of them, like data that is numbers, data that is numeric. Next up, we've got a question about a spinner, and we're asked to explain what is meant by biased towards the number 1. Okay, so this will be when there is a higher probability, or it is more likely, which is fine. You don't have to say higher probability, you could say it's more likely to land on number 1 than any other number. More likely to land on number 1 than any other number. That would be how we explain it is. We've then got some data which is collected from the spinner. Discuss whether or not the information in the table supports what Keshav says. So in order to get 2 marks here, you need to say that the data does support what they say. So for example, you could say that because there is a large number of 1s, in fact more than half the spins are 1s, or indeed that there are much fewer 2s, 3s and 4s than expected. So 1 mark is going to be from your observation, either of these is fine, and the other is agreeing with Keshav, what he says, that the data supports what he says. The spinner appears to be or is biased towards the number 1. Well done if you've got that. Our final question here is how this can be improved. Now essentially, if there was a bigger sample size, that would be great. So our answer here is increase the number of spins, repeat the experiment, do it more times, any word to that effect. And here's 2 examples of how you might write it. Just bullet point is fine. Next, we have a 2-way table that needs to be filled in. So in our first row, we can see the total is 41. There are 35 fruit scones. We need to subtract 35 from 41, which gives us 6 plain scones. Next up, we can see how many fruit scones with egg sandwiches there are, how many plain scones with egg sandwiches there are, and add them together. 20 plus 19 gives us 39. So we've got 39 egg sandwiches in total. And next up, we can have the total number of fruit scones by adding 35 and 20 to get 55. Next, we've got some probabilities to work out. First of all, we need the probability that a customer ordered a plain scone. So there are 25 plain scones. There were 80 customers. So 25 over 80 is all you need for 1 mark. Now you could have what this is simplified to, for instance, or what this is as a decimal, which you might have, so we'll show it. It would be 5 over 16 if we simplified the fraction, but there are no marks available for that, so we suggest that you just leave it as the fraction that you start with. It might be that you've gone for a decimal here, and again I'll provide that. 5 divided by 16, 5/16 as a decimal is 0.3125. Okay, I would recommend though sticking with that original fraction. Next up, egg sandwich and a fruit scone. So here we're looking at this cell in the two-way table. So we're looking at 20 over 80. Again, this is enough for a mark here. You don't have to simplify, but you could have. It would be a quarter, or you might have it as a decimal. That would be 0.25. And then finally, did not order a ham sandwich. Now, the total number of people who did order a ham sandwich is 41. The total number of people who didn't is 39, because the only other sandwich option is an egg sandwich. So one of the marks here out of the two is for getting this 39. That's your numerator. We're writing it as a fraction. The denominator is 80 again. So 2 marks for 39 80ths. Now, if you have decided to write this as a fraction, your answer would be 0.4875. But our recommendations as the maths team is we're writing those fractions, and then we're potentially saving time because we don't need to simplify. The next question is also about the scones again. Lindsay, who is our person in this question, needs to place an order for more scones. And we're using the information to help her decide does she order more fruit scones or plain scones. So the 2 marks here are for assessing which one of them Lindsay needs to order. The second is a reason. She needs to order more fruit scones, okay? So that's one of your 2 marks. How could we explain this? One way is by saying they are more popular, that is all you need. Or you could use the numbers, 55 fruit scones were bought versus 25 plain scones. It's not 3 marks, it is just 2. So this is just another way of getting the second mark. And that question's gone. For our next question, it is about an investigation and some sampling. First of all, we need to name the sampling method, and the sampling method is called quota sampling. You don't need to write the word sampling, that's why I've wrote it in brackets. Just the word quota there is enough for the marks. Next up, the population for this survey. A couple of different ways of getting this 1 mark, but it relates to the same bit of information. It's about and we'll highlight it here, the 30,000 visitors, right? The 30,000 visitors or customers on the day, or all visitors to the park. Now on our next question, we're asked to assess Naveen's plan to get the opinions of the people who have visited the theme park. Okay. Now there are 3 marks available for this, and essentially you can pick 3 of these things. So you should be reading your answer and looking for 3 of these things. Point 1, it's not random. Okay, she's not selected these people randomly. Point 2. The method that she's chosen is relatively easy. Point 3, it does allow for comparisons as well. Point 4, and another benefit here, she doesn't need a sample frame to do this, and that's a benefit. Point 5, bit of a negative here, that's the idea that it's only people's opinions from one day, so it doesn't tell you about, say, another day, for instance. Next one, face-to-face is expensive, right? Because Naveen is doing the survey, that stops her from potentially being able to do something else. It's taking up her time. And also being face-to-face could lead to bias as well, because You might be more likely to tell someone a positive answer about the theme park if you know there's someone who's working for the theme park. So it could lead to bias, big keyword there. And maybe what you might say, and another point if you've got this, they should do a questionnaire instead. Next up, it is a small sample compared with the total visitors, because it is just 60 people, okay, compared to 30,000 per day. So you should probably ask more people, right? There might be an advantage of it being face-to-face in that if there's a bit of confusion on the questions, you can explain it better. It's also relatively sensible that the questions are asked after they visited the theme park. You know, we could imagine another way of asking questions could be to send this out randomly to people. Then they might not have been to the theme park, or they might not have been to the theme park yet. So the fact that they've been is an advantage. But a disadvantage might be that at the end of the day, visitors might be tired and therefore unwilling to answer her questions, and actually that would mean that she wouldn't have the data that she was looking for. So we need to have 3 of those things, that's all. You could have 3 positives, you could have 3 negatives, you could have 1 positive, 2 negatives, 2 positives, 1 negative. It doesn't matter, you just need 3 things. Next up, we've got some birth rate and death rate comparisons for the country of Malta. So here's your graph. Now, our question was, explain how the graph can be used to support Lottie's conclusion. The total population of Malta has increased between 2000 and 2014. Right. Now, the graph supports this conclusion because if we look at the top line, that is the birth rate. The bottom wiggly line, that is the death rate. And for the entire time period, the birth rate is higher than the death rate for the time period shown. Okay, and that's how we could earn our 1 mark here. The birth rate higher than the death rate. That's all you need. Lovely. Our next question on this was why this might not be correct. This is quite an interesting question. So a reason that it might not be correct is because actually a country's population size is determined not just by the birth rate and the death rate, but actually people moving in and out of the country, so migration. So if your answer mentions, it doesn't take into account migration, it doesn't include migration, or it says people could have migrated, people could have moved out of the country, and so on, that is enough for 1 mark, okay? Now, the next question did require you to use a formula and to do a calculation. So number of births, so that's 4,398, using some substitution here. Multiply by 1,000, and again, I'm not doing this. This is what's going into my calculator. All over, remember that means divide the total population, which is 445,053. So not such a big country, Malta. So this is how we earn our first mark for our correct substitution. And the decimal that gives us is 9.881691114. Now we're asked to give this to 1 decimal place. Hopefully our rounding is good here, that this is 9.9. So the correct answer here is 9.9. Lovely. So our next question requires us to fill in a Venn diagram. What I've done is I've drawn the structure of the Venn diagram first. So we've got 60 people. Have they visited France or Spain? 17 people visited both France and Spain. So that's the first thing that we're popping in. It's the intersection of 17. Okay. Next bit of information. 23 people visited Spain only. Again, relatively straightforward. That's going to be this part of the Venn diagram. Now, 33 people visited France. Now this means that the total of 17, and a mystery number here, will be 33. So you have to do a calculation here. You've got to do 33 subtract 17. That gives us 16. So 16 goes in this box here. 16 goes in this box here. Lovely stuff. Right. We have one more thing to do though. What we haven't done is include the people who have been to neither, because we know there's 60 people. So the calculation that we're doing here, I'll do it at the top of the page, is 60 subtract the sum of 16, 17 and 23. So, apologies, went blurry a second there. 33 plus 23 is 56. So we're looking there at 60 subtract 56. That gives us 4. So 4 goes in that box there. Okay? Meaning, or anywhere outside, as long as it's still in the box. Next up, we're assessing validity. Validity of 2 statements here. First statement, more than half of the people in her sample have visited France. The second statement, therefore more than half of the people in her town have visited France. The key words being here, in her town and in her sample. Okay, so the first one then, okay? The first statement is valid, okay? This is because 33, which is the amount of people that have visited France, is higher than half of 60. 33 is greater than 30. Now, the second statement, we can question, okay? So for the second statement, the idea that more than half of the people in a town have visited France, we can question because we can't be sure. This sample, this 60 people, may not have been representative of the people in the town. So therefore we just do not know. What else could we potentially say? Well, we could say that this sample of 60 is maybe too small. In fact, we don't know the population size here, okay, in this town. So we don't know the share of 60 from the town that this represents. Okay. So our next question is a cumulative frequency step polygon, which shows information about the number of goals scored in the German women's national football team. Okay. Now, our first question here is to work out the. Sorry, no, that's the second question. Our first question is to give a reason why a graph like this is used, the cumulative frequency step polygon, to represent this information rather than a curve. And this is simply because the number of goals scored is discrete. So the number of goals scored would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are discrete. It is discrete data. The next part of this question was that you needed to calculate the mode. Okay. Now remember, mode means most common. So what we're looking for here is actually the biggest jump. The biggest jump. And that is here. Okay, that is here. And if we follow it down, straight edge might help here. We can see that that's in line with the number 4. So the mode is therefore 4. Well done if you got that. Final few questions then here. The number of matches where exactly 6 goals were scored, that was 0. Okay, that was 0. More than 6 goals, that was 5. Next up, in 24 matches fewer than n goals were scored, the value of n there was 8. Okay, so in 24 matches fewer than 8 goals were scored. And then last but not least, Clara tries to calculate the interquartile range of. Okay, I'll start that one again because I was briefly interrupted there. Clara tries to calculate the interquartile range IQR of a number of goals scored. She gets an answer of 14. Explain how you know that the answer is incorrect. Okay, the range is 10, so the IQR must be less than 10. Right, so if we go back to our graph, okay, the most goals that were scored is 10 goals. Therefore, all the goals are between 0 and 10, so the range is 10, right? The maximum number of goals is 10 as well, would also score you the mark there, just the 1 mark there. Thank you, and that is it.